introduce our next guest speaker. He graduated from MIT with Ph.D. and since then he has been devoting in the IT industry for over 2 decades. And now he is the Senior Director of Microsoft Research Asia. And this lab mainly focuses on inventing and researching on the next generation multimedia. Ladies and gentlemen, please welcome our next speaker, Dr. Eric Chang.
Thank you. Good afternoon. First of all, thanks to the organizer for the honor of giving the talk here today to give you an update on the work that we're doing in Microsoft Research. So, so today we're going to talk about AI. AI is a very hot topic. So you might have heard of this white paper published by the White House last year. So AI is such a hot topic that even the White House actually decided to organize a panel and actually write a white paper about the impact of AI on government, on industry, on society. So when we talk about intelligence, let's sort of think about intelligence on multiple levels. So I want to recommend this book to you. So this is a book by a Nobel laureate, Daniel Kahneman, called Thinking Fast and Slow. So Thinking Fast and Slow, which is basically, he's basically a professor of psychology at Princeton University, but he actually won his Nobel laureate in the category of economics. So basically, the idea is that when you are thinking, there are different modes of thinking. So what are different modes? For example, thinking fast. Like looking at this picture, you probably think, oh, that's a cat, right? You don't really need to think. In fact, if you ask you, why it's a cat, you cannot really tell why it's a cat. I mean, you just instinctively says that that's a cat. So there are things that we do that's just basically by instinct because of all the experience and the pattern recognition we've done over the years. So there are things that are a little bit slower. For example, so this movie is a tragedy or a comedy. So how many people think it's a tragedy? Raise your hand. How many people think it's a comedy? Raise your hand. Okay. How many people are asleep? Raise your hand. Okay. So basically, this, you might actually notice that this is Jim Carrey's, right? So usually, if you recognize this is Jim Carrey, your guess would be, oh, well, Jim Carrey mostly is in comedy. But if you go search online for this particular movie, it's actually a movie called 23. And this movie is one of the rare movies for Jim Carrey that's not a comedy. So basically, there's sort of a thinking slow where you need to look at all the data you have and so make some interpretation. So that's an example of thinking slow. And there are some that requires really very careful deliberation, right? So example like this, like last year, we actually spent over $20 billion to require linking. So certainly for a decision like that you make once in a decade or maybe even once in a lifetime, then it requires a lot of thinking, a lot of analysis, right? So that's an idea where you actually need to spend a lot of time thinking. So where can computer help us today? So I will argue that in sort of this kind of instinctive thinking fast type of scenario, computers are actually getting pretty close. So if you are in computer vision, you might know this data set called ImageNet, which is basically a very large image set assembled at Stanford, where they basically have like over 1,000 categories of images you're trying to classify. So you can see that a Stanford Ph.D. actually tested himself to see how well he can do on this task. And a Stanford Ph.D. actually got about 5.1% on this task. And then for Microsoft, we actually introduced a new system, like a 3.5% error rate. So why is that the case? Well, you think there are many, many different categories, right? So if you use a deep net has sort of almost infinite memory. So you can actually remember a lot of features. So one example might be in these 1,000 categories, there are like 10 different types of birds. So for most of us, we actually don't know the details of what a bird is, like which category bird it is, right? But the ImageNet is a task where the computer has an advantage because it actually can remember all these fine features. So in terms of deep net, in 2012, when the professor at Toronto, Alex Hinton, he actually started with 8 layers, right? And then in 2015, when we actually did our best result, it was over 152 layers in deep training. So what does that feel like, right? 152 layers is actually very, very deep. So you can actually capture a lot of information from all the training data, extract that feature, and then sort of create this representation that allows you to actually recognize all these different fine features. So what can you do with the neural net? So for example, given the image like this, you can actually interpret all the different objects that occur in the scene. For example, like there's a cake, there are people in the scene. You can actually get probability of these different things, right? So basically, it allows you to interpret what's inside the image. And after that, you can actually do even better. You can actually do segmentation. So what we mean is like we do what we call instant segmentation. So you can see that in this photo, originally you just do the bounding box. So you say that's a person, that's another person, there are two motorcycles, right? But now on the far right, you can see that we do instant segmentation. We don't necessarily tell you that what objects are there on the scene. We actually give you the boundaries of different things. So in fact, the two motorbikes are actually overlapping with each other, adjacent to each other. But we actually, based on the models we have in the system, we can actually build a boundary between the two, right? So that's an example of basically how much computer vision can do nowadays. You can actually define very close boundaries between two objects. So there's a new task offering ImageNet called COCO segmentation. So we actually did this task where we actually have to segment out all the different objects in the scene. So you can see that in 2015, our lab actually did the best. So we actually got the best result. And so the number 2 was the Facebook AI Research Lab. And this past year, 2016, we also got the best result. And the next best result was from Google. So we're definitely a leader in terms of basic research, in terms of identifying the best algorithms to actually create a system that can actually do this kind of recognition. And then what you can do with that is that not in terms of just images, but even videos, you can actually segment out the objects in the video. For example, if you have a robot in the home, you can say, oh, that's a desk, those are a sofa. If you have an autonomous vehicle, you can say, oh, there's someone like this on the road, right? So you can imagine that in a lot of scenarios, whether it's a robot, whether it's an autonomous vehicle, you need technologies like this that will help you to segment out all the different objects in the scene. So once you actually recognize these objects, then you can make determination what to do with it, right? So this is very important both for industrial setting. For example, that Zhang was showing that robot in the warehouse, right? Where you certainly don't want to bump into workers while you're working in the warehouse. Or it could be for a consumer thing. For example, when you are taking like photos, and then you can now have the system automatically tell you what's in the photo. So we actually did very well on this task. So last year there was a task on COCO image segmentation, where we actually sort of have to give attributes and captions on each image to say what's inside the image. Basically, give a one-sentence description of that image, and we're actually the best on that as well. In addition to images, we also did this for video. So you can see that for a given video, we can actually take the sequence of images in the video, and we can give a one-sentence description on the video. So you might ask and say, why is this useful, right? So I'll give you a consumer scenario. So a lot of people now travel, and actually they bring these action cams, right? They actually capture a lot of video on their vacation. So after you come back, you might have 30 hours of footage on your action cam. So how many people will actually go back and look at those 30 hours of footage? It's very hard, right? Because you are busy after you come back from vacation. Imagine you allow the system, the intelligence in the cloud, to actually interpret the 30 hours of video. So you can actually issue a query and say, show me the scene where my son was blowing the birthday cake, blowing up the birthday cake handle on the beach, right? So you want to show this to his grandma. So you can actually give that verbal query. It actually understands that video footage. And actually, out of that 30 hours of footage, it takes out those 15 seconds where your son was actually blowing the candle on the beach. So that's a consumer scenario, right? So we are actually putting all this intelligence in the cloud. So today, my topic is actually enabling pervasive AI through intelligent cloud. So you can see that we have actually a lot of different sort of like capabilities. So like for example, in speech, in computer vision, in language, and then in search, right? So the benefit of that is that Microsoft basically is one of the companies that has a broad range of technologies in all these different areas. So one example might be like when Zhang was talking about sort of like picking a song, right, or choosing a song. So well, Microsoft actually has a search engine. So if you ask about, give me the latest song by Madonna, it actually knows Madonna is a singer, right? It actually is a graph, a knowledge graph about Madonna. It knows which records have been sort of like published by Madonna. So you can actually look through all the different records and then find the latest song, right? So that's where a search engine might help you. And in terms of machine translation, we actually have done machine translation for over a decade in commercial use. So you can actually allow the use of machine translation to actually sort of help to interface between the user and the machine. And also in terms of speech and vision, there are all these different services. So some examples that are real, that's deployed today, right? So in face recognition, we're actually working with Uber in the US. So Uber has a challenge in the sense that Uber has over 500,000 drivers around the world. And these drivers are certified and approved, right? But how can they be sure that the actual driver driving the car is actually the person who registered? So Uber worked with us so that they can actually challenge the driver, right? Every now and then they can challenge the driver and say, take a selfie. So this selfie is sent up to the cloud, and they can verify the selfie against the record to say, this is actually a driver, so that there's an enhanced layer of security, right? Or another example is Coca-Cola. So Coca-Cola was doing marketing campaign. So they asked people to send in photos, right? So they need to identify whether this person is actually what the face is and whether the person is like smiling or not. So they can use the face recognition API in the cloud to actually assess all these different selfies that people send in to Coca-Cola in their marketing campaign. So in terms of machine translation, so if you use Twitter, for example, and then someone have a tweet in Japanese, so you can press a button, and then it will actually translate it to the language that you understand, right? So that's using the recognition engine from Microsoft. Also, one of our large customers is actually online game providers in China. Is these online game providers, they are actually providing services now, not just in China, but also worldwide. So when their players actually want to interact, they want to chat with, like, for example, a player in Japan want to chat with a player in the US, right? The machine translation system can kick in and actually translate all these chat. So there's more engagement. And then in terms of Nuance, which stands for Language Understanding Intelligence Service, we actually have these custom bots that have been built by both governments and by companies like CITIC, where it's basically a helpline, essentially a chatbot that can actually answer all types of questions. So it's a much more friendly environment, right? So imagine, for example, the government of Singapore. This is one example. So they have like many websites targeted toward business. If you want to start a company in Singapore, there are different websites. One for like learning about tax, one about employment, one about visas and things like that. So what they want to do is basically having a chatbot that basically should understand all these different domains. So basically, you can just ask of the chatbot essentially all the questions you might have. So you don't need to actually go to these different websites. It's a very simple process. And then we also have like a handwriting recognition so that you can do both printed optical character recognition and also handwriting optical character recognition. So here are some examples of what you can do with the APIs, right? So this is a demo we have called captionbot.ai. So basically, you just send an image, and then this is what's generated. I think it's a young man jumping in the air on a skateboard. So imagine, essentially, given an image, it can actually give you a natural language description of that image. Or this one is, I think it's a sandwich cut in half, right? So basically, you can imagine that the power of AI is actually able to interpret these images and help you to index these images. So you actually go through and look at all the images you have. So imagine all the different startups out there, right? They want to actually create all these different vertical scenarios. The image recognition can actually provide a lot of powerful functions. And we can also do the same thing for video, right? So you can imagine that taking a video, then you actually can say a man is cutting a piece of meat, or a man is performing on stage. So all these are examples of what we can do with vision, computer vision with videos as well. So the scenario I said about the action cam, that's one thing. But also it's also for like industrial settings. If you have autonomous vehicles that's roaming around an industrial park, then actually you can actually recognize different things as the bus is roaming. So these interfaces are very easy, right? It's basically just a web API, so you can create very easily apps. So on the far right here, howold.net, a lot of you might have like played with this about 3 years ago when we introduced this, right? So basically, on Facebook, it's very popular. You set up image, and then people will start sharing and say, this is like a female, age 4, right? And the nice thing is actually, it was actually a very simple application to develop. You only about 9 lines of code to actually call the Microsoft Web API, to actually use this kind of powerful technology created from years of research at Microsoft, right? So anyone can actually very easily create apps or vertical domain systems that can leverage all the AI capabilities. And we actually just introduced, just this month, something new. So it's called customvision.ai. So what customvision.ai is, right now, a lot of image recognition APIs, they give you a fixed set of tags. So basically, you send an image, it has like indoor, outdoor, right? It has basically like man, or it has things like a car or cats or things like that. So with this new API, what you can do is you can upload your own images. And with your upload images, will create your custom classification system based on the images you upload, right? So like, for example, if you want to do plants, you decide to do like an app that will detect various types of flowers, then you can actually upload the different flower images onto the cloud, and the cloud will train up a recognition system for the different flowers. So to give you an example, right, so I love ramen, right? So we're lucky here in Taipei, there are a lot of rich variety of ramen, right? So for example, I can just upload a bunch of images of ramen, right? And say, oh, this one, it actually has an egg and it's a ramen, right? And then so basically, if I love Japanese food, which I do, right? You can actually upload images of sushi, the tempura, and then basically ramen, right? And actually then you will actually start index all the photos you've taken with the different tags, right? So if you are writing a travel blog and you want to find that particular ramen like in Tokyo, this will make it a lot easier, right? Whereas, and we all have different needs, right? No one will have the same set of tags. So this makes it super easy for people to actually create their own tags and then actually upload the images they care about. Like for example, I have another friend who might care about Chinese calligraphy. They actually really admire Chinese calligraphy. So they can actually have a tag that's just a Chinese calligraphy. So once he goes to the museum, he takes a lot of photos of Chinese calligraphy, it'll be very easy for him to find all the images that he has of Chinese calligraphy. So let me move on to the next phase, which is basically sort of thinking moderately slow, right? So it's comedy or tragedy. That's the example, right? So let me give an example of dialogue. So dialogue, you might have heard of Cortana, which is basically what we introduced worldwide as a way for people to have a productive assistant to help you to like manage your schedules and things like that. But we also have basically Xiaobing in China. So what Xiaobing does is focus on the EQ. So what does it mean that focus on EQ is it actually chats with you, right? Have a long extended dialogue with you. In fact, right now we're getting to 23 interactions per session. So Xiaobing is really designed to be like your friend essentially and chat with you. And now we have actually introduced it both in China and Japan and in the US. And we actually have a lot of partnership with a lot of different companies that you can see below. Like for example, in Japan, we actually work with Lawson. So actually Lawson's app will actually have a Xiaoi's or Xiaoi's built-in, right? So you can actually chat and actually you can also offer you coupons and things like that. So it's a way, for example, for an artificial intelligence agent to interact with the user. And let me give you an example of what kind of interaction you can do with Xiaoi's, right? So first of all, you can actually send an image to Xiaoi's, and Xiaoi's will actually not just recognize the image, but also comment on the image. So example is this, right? So you show an image of a dog. So not only that you recognize what kind of dog it is, like Bull Terrier, it actually finds online, different people's comments about Bull Terrier, and then say, oh, there are actually two actors who actually look like Bull Terrier. So it actually generates kind of dialogue with the user based on the image and based on the knowledge graph that we have in Bing. So another example is that this is the work with the JD.com, right? So you can send the cover of a book. So now in addition to actually understanding which book it is, it actually goes back to all the book review websites and say, oh, this is actually a book about like industry. So you must be like studying to be like an industry leader, right? Or for example, for fashion, right? You can actually send an image of a fashion. It actually give you a grade on your fashion sense. So for example, so if you have Xiaoi's, it can actually grade your fashion sense versus your friends. Or an example is that we can recognize faces, right? And you say, oh, okay, so people have that, like smiling or the emotion or who looks like who, like something like that. Right, that shows you the ability for AI to actually interpret not just on quick recognition, but also longer term like information as well. So IoT is a big field now, right? And it's actually a very hot field. So what we see is basically you can imagine that IoT is actually consists of the physical world, which you can sense with sensors. And then you have actuators like robots, right? They can actually affect what's happening in the physical world. And then what we do is that we build AIs on top, on decision analysis that's helping to make decisions. So we have a lot of examples like this already, right? So we have a lot of companies that's using the IoT in the cloud, the Azure IoT hub system, to actually do predictive maintenance, right? To operate either jet engines or factories or things like that, right? So there are a lot of real cases if you go to Microsoft's website that's online. So we can do this because there are so many different sensors, but there's only one intelligent cloud. You want an intelligent cloud to be able to access all these different sensors and make decisions and analysis, right? So for example, you can imagine that with all the different features that we have on Azure, you can go from data warehousing, we can actually accumulate a lot of data to actually decide, for example, doing predictive maintenance. So we can look at an example with Rolls-Royce, right? So every time Rolls-Royce takes a flight, it actually generates gigabytes and gigabytes of data. So after it lands, it has to upload this to the cloud, and we can do analysis, right? So here's an example with Rolls-Royce. Sound? Yeah.
With over 13,000 engines in operation around the globe, Rolls-Royce provides the services to maintain them at peak performance. Today, each engine has thousands of sensors that can produce terabytes of data on long-haul flights. Making sense of all that data is critical in transporting my passengers safely and efficiently. Rolls-Royce uses Azure IoT Suite to analyze data remotely and deliver real-time, actionable insights to me and to the airlines about engine performance and operational efficiencies. Advanced analytics help us optimize fuel economy, anticipate maintenance needs, and avoid costly downtime and delays. A single unscheduled disruption and its knock-on effect to a fleet and the passengers can cost an airline up to $1 million a day. With early notice, our team can proactively have parts at the right place and time, reducing inventory costs and maximizing availability. Up to 1/3 of a plane's weight is fuel. As a pilot, I decide how much fuel my plane carries. Insights into engine efficiency, weather conditions, flight path, and scheduled landings impact my decision. Cortana Intelligence helps me choose the optimal fuel level to maximize efficiency. With 40% of our operating budget devoted to fuel, even a small percentage reduction can save us tens of millions of dollars each year. Microsoft and Rolls-Royce, reaching new heights in customer value.
Right? So you can imagine that for a single flight, you can already save hundreds of thousands of dollars if you use the right fuel usage, right? And then next, thinking really deeply, how can AI help us, right? So whether to buy LinkedIn. So in making decisions like that, you have lots of data, right? So basically, we believe that this is basically where AI plus HI can help. So AI is artificial intelligence, HI is human intelligence, right? Because human can actually make higher level decisions and analysis, but machine can actually process volumes of data and actually detect trends and help you understand basically what the patterns are, right? So essentially, we are looking like, in terms of just AI, we actually believe AI plus HI. In a lot of decisions, AI plus HI will actually jointly make the decision. That's the right decision. So I'll give you an example, right? So we actually have a product called Power BI, right? So Power BI basically takes data. It not only sort of provides visualization, it actually generates insight automatically. So let's see how it works. This is actually a database of all the shark attacks around the world, actually, over the past few decades. So basically, just given us this spreadsheet, so you can try this today. You go to powerbi.com, you can upload spreadsheets like this, and our system will actually automatically analyze the data. Sound? Yeah.
Your data. Here are the insights for shark attacks data. Each insight is presented with description and visualization. The insights could be correlations, outliers, trends, dominate factors, and more. Here is an insight telling you there is an outlier in yearly attacks data. You can click to see more. You can see here 1960 is an outlier in the data. To understand what happened in this year, by another click, you can get further insights related to this year.
Right, so
For
exactly,
example,
yep.
Here this insight tells me that spearfishing was the dominated activity in that year, which could be the reason for the outlier.
So you can see that it actually sort of analyzes the data automatically. You can sort of upload all the data from your spreadsheet, or it could be from your SQL database, and you actually analyze and go through, right? So basically, it gives people essentially real-time analysis of the data. So you don't need to rely on having a DBA analyst, right, to actually do a sort of analysis or pull the right query. The system does that automatically for you. Right? So you can think about, for example, how all these AI can be helpful to an enterprise, right? So we have AI infrastructure on below, so you can actually do your own machine learning, or you can actually create your own data warehouses, right? But on the top, we have these automatic tasks, which you can think of as SaaS, for example, right? That can do machine translations and do things like that. And also AI plus HI tasks. So believe that it will be a spectrum, right? So we believe that both developers and also data scientists can benefit from this kind of sort of offering. right? So if you are a great data scientist, you can actually use Azure machine learning and develop your own models. But if you just want to have predictive maintenance or do like a sales forecast, then you don't need to understand any machine learning at all. You basically just upload data, and then Power BI and Azure machine learning have like sets of data and models that are designed for you already, right? So basically, we believe that this will actually be helpful to enterprises large and small. Doesn't matter whether you're in retail, doesn't matter whether you're in manufacturing, doesn't matter whether you're in logistics. You can actually utilize AI to help you to process all the data you're capturing in your enterprise today and make better decisions and become more efficient. And then in addition to the intelligent cloud, we also believe in the intelligent edge, in the sense that there will be end devices that actually are intelligent, that gives you capability. So one example is HoloLens. So HoloLens actually has a lot of sensors that actually understand gestures, understand your surrounding. So it can actually be used to help make your workers more efficient. So here's an example.
Introduction of HoloLens to our operations will empower the over 20,000 field service engineers in doing the job better, more efficient. Increasing availability of elevators and escalators makes the job more safe and more fun for our people as well.
The scenario we have developed is really about dispatching a service technician using HoloLens in very different kind of ways.
So as soon as the technician puts on his HoloLens, he already sees, I have a call here, I need to go to this elevator, and then actually sees a 3D picture of the elevator that he's going to work on, and that he can zoom into a part that will offer you also training opportunities.
He goes to the job site prepared, probably better prepared than ever before, because he has the relevant data available to him in the best format possible, and in a variety of ways he can tailor the data towards his need.
The technician putting on his HoloLens, looking at the elevator, sees the historical notes first, so what has actually happened with this elevator before. He already has all the information right there without having to look for it. It saves a lot of time and a lot of stress and effort.
Gets information on his virtual desktop about the task orders he has to carry out.
The latest safety alerts for that elevator.
He pulls on a 3D replication of that part, pulls it out in an exploded view, and can actually see which part is making the problem.
A major advantage of the HoloLens, of course, is that we are hands-free, and we never had that experience and the capability before.
In the past, the technician needed both of his hands to operate the laptop, and now he just has his HoloLens on.
One of the most important capabilities we see with HoloLens is that we can trigger a remote call to a subject matter expert.
Call Heather.
Hey Jeff, how you doing?
I'm replacing a door board out here, but I kind of wanted you to check a couple things out.
Okay, let me take a look. The JP3 is in the right position and your motor leads are disconnected, so you're good to go.
It takes a lot of stress out, it saves a lot of time, and our field tests have shown that there's a huge potential to increase productivity with that. A job which normally takes 1 to 2 hours and maybe ends up with having the expert traveling to the site, we were able to carry it out on the first time in less than 20 minutes. What we are striving to do at ThyssenKrupp Elevator is really creating new, interesting technologies to build the city of tomorrow.
So each HoloLens, the commercial edition actually costs about $5,000. So ThyssenKrupp is actually going to buy over 20,000 units. So that's a $100 million investment. So this might look very, very science fiction to you, but it's not science fiction, it's reality. People are actually investing big bucks into making this, as you heard in the video, right? A person used to take 2 hours to finish one job. Now it might take only 20 minutes. So imagine the productivity increase, right? So with that kind of productivity increase, then people will be willing to invest. And you might notice the scene where the person actually calling the subject expert to help to say, let me analyze the scene and realize which part to fix, right? In the future, it could well be an AI expert, actually, that's actually looking at the diagram and actually analyzing, giving you feedback. Basically, so instead of a human subject, a human expert, it could be an AI expert that's doing that, right? So to summarize, to talk today, right? So believe that essentially tasks that are really thinking fast, those will be quickly automated away over time, right? And it doesn't matter whether it's in like manufacturing, it could be in like, for example, medicine, it could be like in retail. There are actually a lot of work right now that's somewhat repetitive. So you can imagine that machine can handle that. And then instead, we believe that with AI plus HI, we can actually release human from doing the more mundane and redundant jobs, right? And then actually can focus on releasing sort of more value from creativity, from creating new solutions. And as I said in the elevator example, right, there are actually many, many avenues for creating and generating more value in a lot of vertical industries. Now, today we saw the elevator case, we saw the Rolls-Royce case. Each one of these are hundreds of $millions, if not more, opportunities. So there are many, many opportunities for startups to leverage the intelligent cloud to actually create vertical applications that can actually generate significant value in their marketplace. And Microsoft has traditionally been a platform provider that has worked with millions of developers around the world. And we have actually done a lot of collaboration with companies here in Taiwan. So we really believe that it's actually a great opportunity today to actually work together to actually release the power of AI and make AI pervasive through the intelligent cloud. Thank you very much. Thank you.
Ladies and gentlemen, thank you, Dr. Eric Chang. Thank you, doctor.